In today's lecture, we cover 4.3, tangent and cotangent. Let's start with tangent. Tangent is the ratio of sine over cosine. Now we know that there are locations on the x-axis where cosine is equal to 0. Whenever cosine is equal to 0, we end up with a fraction where we are dividing by 0, which would make tangent undefined. You may have already observed this on the unit circle, that tangent is undefined at pi halves and 3 pi halves. So what that means for our graph is that we are going to add a vertical asymptote at pi halves and 3 pi halves. Now, since negative pi halves is coterminal with 3 pi halves, negative pi halves is also a location where we find that tangent is undefined. Tangent is different than sine and cosine in that the period of tangent is only pi. So where sine and cosine have a period of 2 pi, tangent and cotangent both have a period of pi. That means that this increment from negative pi halves to positive pi halves, which is an increment of pi, is 1 period for tangent. Likewise, from pi halves to 3 pi halves, we have 1 period of tangent. So on this graph, I will be graphing 2 periods of tangent. And that's important for you to see because remember that tangent, like sine and cosine, is periodic, which means it will repeat as identical copies to the left and to the right. But unlike sine and cosine, tangent is not continuous. So how do you graph a basic tangent graph? Well, first, we want to plot some points. So let's make the observation that at 0, tangent is equal to 0. Next, the value at pi force for tangent is 1, and at negative pi force, the value is negative 1. You can get all of these values from the unit circle. When you are graphing tangent, what I'm going to be looking for is that you put the asymptotes in the correct place, that you put 3 central points in the correct place, and then that the shape of the graph is generally correct. So I realize that we don't graph as perfectly as a graphing calculator, but your general shape should be correct. And the shape is a little bit like x cubed, except whereas x cubed will continue to the right forever, this will be bounded by an asymptote. But it should remind you a lot of the x cubed graph. So we're going to repeat this process again. Over here, we have tangent is equal to 0 at pi. Tangent is equal to 1 at 5 pi force, and tangent is equal to negative 1 at 3 pi force. Make sure that whatever happens in here is curvy. You should not be drawing a straight line at any point, okay? So make sure it's a curvy. You have concave down, concave up. Tangent changes its concavity here at 0. So this is the graph of tangent, and now I want to look at the graph of cotangent. Cotangent is equal to cosine over sine. Cotangent also has a period of pi. So because is now the denominator, that means that cotangent will be undefined anywhere where sine is equal to 0. And sine is equal to 0 at multiples of pi. So for the cotangent graph, I will have asymptotes at multiples of pi. One of the asymptotes of cotangent is the y-axis. So I'm only going to be able to graph one full period here, but you'll at least be able to see sine and cosine on the same graph coordinates, which I think is important. Okay, so another thing about cotangent is 0 at pi halves. Cotangent has a value of 1 at pi fourths, just like tangent does. And cotangent has a value of -1 at 3 pi fourths, just like tangent does. So they share these points in common, but they have different zeros. What results is that the graph of cotangent looks a lot like the negative x cubed function, except, of course, that we're still bounded in those asymptote lines. Okay, so now I would like to go through some MyOpen math problems with you. The first is, what is the period of the graph of the function y equals tangent 11 pi over 24? So recall that the default period of tangent is pi. So when it comes to finding the period of tangent, it's going to be very similar to sine and cosine, except that you're going to be using pi instead of 2 pi. So the period is found by taking pi and dividing it by the b value. In this case, the b value is 11 pi over 24. The pi's will cancel, and then you'll end up with 24 over 11. Okay, so then for question number 3, the b value here is 6. So then the period would be pi over 6. To find the horizontal shift, you need to factor out the 6 here. So we could rewrite this as 5. So here I can rewrite this equation as 5 tangent 6 times the quantity x plus 4. This then shows that I have a phase shift. Well, we don't call it phase shift for tangent and cotangent. We just call it horizontal shift. We have a horizontal shift of -4. So that would mean 4 units to the left. Next, we have to figure out which graph is correct. So we want to make some observations here. The first observation that we want to make, we want to observe that we have a -1 in front of the tangent graph. So always keep in mind that the basic tangent graph usually goes like this, in the same sort of orientation as a positive x cubed. However, with the negative in front, that means you're flipping the graph over, which means that the orientation of tangent is now going to be like cotangent. So that's going to eliminate this answer choice and eliminate this answer choice here. Next, we can see that we have a horizontal shift, and this horizontal shift means that we are going to the right by pi fourths. Usually tangent will straddle the y-axis between negative pi halves and positive pi halves, but we can see that this graph has been shifted to the right. So that means that the graph we're looking at would be this one right here. And there's the correct answer, which was this graph right here. So now let's pretend that this says cotangent, and we can answer this one correctly. So cotangent usually has the orientation of negative x cubed. If there's any negative out in front, it will flip it over to look like a tangent. In this case, however, there is not a negative out in front, which means that cotangent will have the negative x cubed type orientation, so we can eliminate these two choices. We can see that both of these choices have been stretched by a factor of 2, so now we're just left to look for the shift. Cotangent usually has its asymptotes at 0 and at pi. So you can imagine the asymptotes are usually the y-axis and about at 3.14. This is where the cotangent graph should be. This has shifted to the left a quarter cycle, which would make this the correct answer because you can see that this is going to be a shift to the left by pi force. So that first answer here is the correct answer. See, now I get it correct because I pretended it said cotangent instead. So as long as you pretend that this says cotangent instead of tangent, you can answer this problem. But otherwise, I will give you full credit for whatever you answer. So if there is a problem with the code, I will always make that up to you. I will not penalize you if it's the code's fault and not your fault. Okay, question number 6. Here we have a cotangent graph with a negative out in front, which means that you're going to have the orientation of tangent. So we're going to eliminate the answer choices that have a cotangent with a positive leading coefficient. These two graphs represent what cotangent usually looks like, but because it has flipped over, it's now going to look a lot more like tangent. Next, we have a shift to the right by pi thirds, which is a third of a cycle. So we want to look for a graph that has shifted to the right by a third of a cycle. And that would be this one, because usually we have a graph between 0 and pi. And so the graph would have a center point right here. But the graph has been shifted a little bit over here to the right, and that then makes this the correct graph. There you go. That one right there.